Hello, in this video I want to introduce international trade. So what we have here is a particular country, and that country has some resources, L, technology as exemplified by the unit labor requirement, which will give us this PPF, and then there are some preferences within this country, which is just given by this utility function, and we could draw that as an indifference curve. And then we're going to introduce another country who has a different set of resources, technology, what have you. And because of those differences, there's actually a terms of trade, an international price, if you will, that is given by this TOT here, terms of trade. And that's going to give us a trade line. And what it will do is allow this country to disconnect its production point from its consumption point. So in autarky, when you cannot trade, then of course what the country consumes must equal what the country produces. But with international trade, we can separate those 2 points so that a country can produce a different mix of the 2 goods, A and B, than it chooses to consume. All right, so that's going to be the key to the benefits from international trade. And that's what we're going to be looking at in this video. All right, so I'm going to go quickly here first because I'm just going to determine what our autarky position is. So again, we know if the resource is 100 units of labor, unit labor requirement is 2 for good A, and unit labor requirement is 4 for good B. And our utility function is a standard Cobb-Douglas utility function. And then later on, when we go away from autarky, our terms of trade is going to be that it takes 4A to, or you have to trade 4A to get 1B, or alternatively, you can trade 1A for 1/4 of a B. But first I want to do the autarky, so when we don't have any trade. So the first thing that we will do is draw the production possibilities frontier for this country. And I have already started that. I drew it. I'm just going to go ahead and put in the intercepts. So of course the maximum amount of good A we can produce is 50. That's just L divided by ALA. And the maximum amount of good B we can produce is 25, which is L divided by ALB. And then, this red line shows all the points, all the combination of good A and B that the country can produce, given its resources and technology. But we want to know where it would actually want to produce if we had no trade and given our utility function. So the solution to that would have been, to maximize utility, which is given by this consumption of good A according to the standard Cobb-Douglas, subject to our PPF, the equation of the PPF, so 2QA plus 4QB equals 100. All right, so from intermediate microeconomics, you probably remember that the optimal amount of QA would be equal to the exponent, 0.5, times the income, if you will, which is in this case is the number of workers, divided by the price, which is unit labor requirement. So the optimal amount for consumption will be equal to 25 of good A, and the optimal amount of consumption of good B will be equal to 12.5. So what we have here is, of course, 1, 2, 3, 4, 5, our autarky production and consumption point would be at a point just like that. And if I just kind of traced in an indifference curve, the indifference curve would look something like this. But what I'm going to do now is introduce trade. So we have another country, and because of that other country there is an international price. The country is different from the first one, and the international price is 4A for every B. So first we have to determine what is this country's comparative advantage. Like in which good should they specialize according to comparative advantage? And then, given that they produce that good, we can then draw in our trade line, which will show where the country will choose to consume. So let me go to another slide. All right, so what we have here, so I'm going to first determine what the opportunity cost for this country is in terms of good B. So it'll be ALB, ALA, which was 4 divided by 2, which is 2A. So we notice that this 2A, that's less than the terms of trade, which was equal to 4A. So this country has a comparative advantage in good B. All right, so if it specializes according to comparative advantage, then we know that the country will be use all its resources in the production of good B, which would be equal to 100 divided by 4, so that would be equal to 25B. All right, so let me just sketch that in here real quick. So we have that this country, they would be, somewhere right around here in autarky. So in autarky, they would be producing and consuming right there. But with complete specialization, according to comparative advantage, they will be producing up here instead. So this is going to be our production point. And then, because we know the terms of trade is 4A for every B, so for every B that they send out, they will get 4A in return. Right, so of course this PPF here was for every B you forego, you get 2A. So the trade line is going to be flatter. In fact, if we kept going, you would of course get that there will be 100A over here. I'm going to stop there. So this is our trade line. And there will be some point on this trade line that maximizes this country's utility. And of course, you can see that already the trade line is outside of the PPF here. So this outside of the PPF, so we know that if you trade according to the terms of trade, you should be able to get to a point where you have more of either A or good B or both. And the question is, where on that trade line we would like to be. So that's what I'm going to try to solve right now. The first thing we have to do is, of course, maximize our utility. But now, and this is going to be really interesting, now our resource constraint is very different. So let me first write it in general. So what we have here, if they specialize in, according to comparative advantage, then they will be producing QB, and they can produce 25 units of that. However, they will consume, or the quantity of QB that they consume is going to be reduced by the number of good B that they export. And then for QA, that's going to be equal to the terms of trade for good B times the number of good that they export. All right, and of course in this case, the terms of trade for good B is equal to 4A. All right, so if I simplify, and I'm going to substitute the second constraint into the first because we have the same x there. So what I get then is 25 minus, and x is equal to 1/4 QA, so 0.25 QA. And then I'm going to plug that into my utility function. That is, I'm substituting it in for my QB. And then I'm going to take the derivative of this with respect to QA. And, all right, so I'm going to go, we know how to do it. We take the derivative the first time, multiply by the second term, plus the derivative of the second term, and we don't forget the inside, minus 0.25, times the first term, and we're going to set that equal to 0. And then we're going to move one of these over to the other side. We're going to simplify by, we can get rid of some of this 0.5. And if I just go ahead and do this, what I get is 25 minus 0.25 QA equals 0.25 QA. 25 is equal to 0.5 QA. QA equals, of course, 50. And therefore, QB, using our constraint up there, is 25 minus 0.25 times 50 equals 12.5. So what I have just found here is where we want to be on the trade line. So it's not going to look exactly right because I didn't draw my trade line is something like this. And our consumption point is going to be right there. Because the indifference curve, that's the way we have chosen it, would be tangent to the trade line at that point. So let me just explain what we're doing here. So first, this is the 50. And of course, over here is our 12.5. And just to remind us, we were producing 25 and consuming 25 in autarky. So what has happened here is that when we specialize according to comparative advantage, we are producing here, and then we are trading good B for good A until we get to a point where we have just the right amount of good A and good B to maximize our utility function given these new constraints. So you can see that if we just, we can of course solve for the number of exports that we had. So exports here is going to be equal to, 25 is what we produce of good B, minus what we're going to be consuming, which is 12.5. So we're going to export 12.5, and in return, we would get 12.5 times 4. So this is 12.5 B, A. So we get 50A in return. And of course, that explains our consumption point right there. All right, I hope that makes sense.